Okay guys, so we've got a very brief sample question. Now the math in this is going to be super easy. The difficult thing is going to be understanding the basic idea behind this. So here we've got a car of mass 400 kilograms and it's traveling at a velocity of 15 meters per second. Calculate the momentum. Super easy. All you're going to do is number one, make your list as always. So the mass is 400 kilograms. The velocity is 50 meters per second. The momentum is unknown. Now I know you guys are going to get really careless about this, and quite often I do too. But it's important for us to realize a couple of things. Okay, the first thing is momentum is a vector, and it's a vector because velocity is a vector. If you notice here, velocity, I've drawn it on the diagram of my beautiful car, and it's pointing to the right. Well, momentum is also a vector, okay? And that's the tricky bit that everyone forgets, and that's why I'm actually making this video. Okay, the math bit is super simple, like I said. All you do is you write your equation, you sub in your two values. The mass is 400 kilograms, the velocity is 50 meters per second, and the overall momentum is 20,000 kilogram meters per second. And of course, another way of writing that is to say that it's 20,000 Newton seconds, and we'll come to why that is later on. It's got another unit as well. Of course, kilogram meters per second can also be written like this: kg on top, meter second to the -1 on top. Okay. So let's back up for just a teensy little bit and understand why I've gone to the trouble of making this video. I mentioned it already. Velocity is a vector. Okay. Everyone's going to forget about this. I know they will. And in forgetting about it, they will inevitably make mistakes with momentum questions. Okay. Velocity is a vector and points in this case to the right. Now if you look at the equation for momentum, it says is a vector. Mass is not a vector. That's just a scalar. It's just got a value. It does not have a direction. But if you notice, momentum is a scalar multiple of another vector. Okay? It's a scalar multiple of the velocity. So in other words, whichever direction the velocity is pointing, the momentum must also be pointing in that same direction. So it's a little bit like Newton's laws, if you remember. Newton's laws says that the net force is equal to the mass times the acceleration. And again, I'm including that little vector symbol on top. Well, what that means is that the acceleration is a multiple, a scalar multiple, and again it's multiplied by the mass, believe it or not, of the acceleration. So in other words, whichever direction the net force is in, the acceleration also has to be in that same direction. And in this case, very similar. Whichever direction the velocity is in, the momentum has to be in as well. Okay? Now trust me, that's a bigger concept than you might think, and that's why I've gone to the trouble of making the video of this. Okay, so don't overlook that idea. Okay, so if I'm going to represent them as arrows, well, a vector arrow for the velocity, that might do for the velocity, but obviously this is not going to be to scale or anything like that, because the velocity is only 50 meters per second, whereas the momentum is massive. That's 20,000 kilogram meters per second. Okay, and again can be represented by an arrow, and that size of that arrow should point in the same direction as the momentum itself, and the size of the arrow should be representative of the size of the momentum. Okay, Hopefully that makes sense to you. I know I've probably over-labored the point, but I feel it's important.